Şimdi Hasan hocamız bize bir sunum yapacak, tema konuşması yapacak. İklim 2030 yılında benim sözünü ettiğim iklim nötr şehirlerle buluşacak bina teknolojilerinde yeni trendleri anlatacak. Yani bu amaca ulaşmak için bina teknolojilerinde yapılan araştırmalar, buna yönelik çalışmalar ve onların ürünlerini anlatacağız. Söz sizin Hasan Hocam. Yarım saatiniz var. Buyurun.
Thank you very much, Professor Uyar. And I also thank you for inviting me, as usual, to the IRENEC meetings. It has been a custom. It's now that I also join every meeting. So this time I would like to introduce new trends in building technologies to meet the climate neutral cities in 2030. What are we going to talk about in my topics? Zero energy buildings, of course, as usual. It's an important element in the transition. We will talk on climate change actions, what happened recently, the European Green Deal, very briefly, of course, and then there has been some changes to the energy performance of buildings directive in Europe. Then we go into more technical things like how do we use insulation to achieve the topic, renewable energies, electrification, digitalization, smart technologies, and finally, in the energy performance of buildings directive last proposal, they propose an energy performance software to be adopted. So I will talk, we have been doing this in Turkey for a long time. So I will just mention that here and conclude my talk. Okay, so we start with usual statements saying that energy is a major input. It plays in the economic development of societies. Fossil fuels are diminishing. Greenhouse gases are dangerous, and therefore, we have to use energy efficiently. And then let's have a look very briefly on how we stand in Turkey. I took this from the Mechanical Engineers Chamber presentation that was published recently. This gives an outlook of the energy demand in Turkey in 2020. That was the most recent reference I was able to obtain. But here we see that the share of renewable energy, especially wind and biomass and solar, is becoming more and more apparent in the perspective, because 10 years ago, this was all these renewables were shown with just a single piece of the pie, saying renewables, because they were so small. So that is a very promising development that we are actually trying to work towards renewables. However, in the can you see the pointer actually? Well, anyway, the
pointer we cannot see pointer. Oh yeah, I think yes.
Okay, so in the lower right corner, there is a summary, but we still are importing our energy, 70%. That is a very high percentage. And although developments are seen in the renewable energy part, we still rely on fossil fuels. 83% of our energy production depends on fossil fuels. The electricity generation from renewables has been 36% last year, and it stayed about the same percentage in the first months in 2022. And 12% of this total production, of course, the renewables are from hydraulic dam type power plants, and 5% from solar power plants, which is a very nice figure actually. Although we are not able to achieve the figures of China, for example, but still I think Turkey is doing a good job there. And here we see a chart on the electricity demand view. The light blue is year 2021, and we can see that electricity use is becoming also more and more, and every year, which is also a good indication, because as you will see in my coming slides, electrification is an important part of switching or translating to renewable energies, and of course decarbonized cities and so on. So electrification is an important issue. So in that respect, using more electricity gives a good trend for us. Okay, so zero energy buildings now coming into the elements. Of course, this is not a new subject, but it has been mentioned in the energy performance of buildings directive before, so that the member states should be using, especially in new buildings and in public and private buildings, from year 2021. So we already passed that, and they are not performing bad, I would say. An energy zero energy building is a building that uses very little energy, and mostly from renewable sources produced on site or nearby energies. Okay. So member states have been working towards this a lot, but they have not come to a very perfect point so far. Spain is one of the pioneers, let's say, of doing this, and they are about to include new zero energy, nearly zero energy buildings in their legislation. Okay. Now, of course, the definition in the EPBD is very flexible. Therefore, the definition of a nearly zero energy building changes from state to state depending on geographical conditions and, of course, the energy structure in that country. So that is why we see different definitions of nearly zero energy buildings from country to country. That is something we can't avoid. Okay, the European Union has also initiated projects regarding this. Zebra 2020 is one of these projects, and in this project, the European market is tracking the nearly zero energy buildings, which they call a zero energy building radar graphic. And from this, you can somehow compare and follow what people are doing in these regions. The Zebra project defines buildings in 4 levels. One is the net zero energy building. This is our basic goal, actually, or plus energy buildings. Plus energy buildings are buildings that actually generate all their energy need from renewables, and they have a surplus which they can sell to the grid or allow other users to benefit from this renewable source they are creating. Okay, then there are nearly zero energy buildings according to national definitions. That's what we have been talking about. And then we have buildings that achieve the requirements of 2012. 2012 is kind of like a starting point or a reference point. So we have to have a reference point to start with. So 2012 is a good date to start with. So the next 2 categories are buildings that meet the requirements of 2012 and they perform better. And the last segment is the buildings that just make the requirements. several countries have, of course, have made plans, targets to achieve net zero energy emissions by 2050. This date may seem to be too far away, but I remember myself when we were in the early 2000s, we were talking about 2023 and 2030, and we were saying, well, we have a long way to go. But as you know, we're almost there. 2023 is next year, and 2030 is 5 years from now, approximately. So time passes by very quickly. So 2050 is not a very far away date. Okay, so to achieve this goal, countries can have different strategies. One way of doing it, or an easy way of doing it, is to start from lighting and HVAC equipment, because HVAC equipment, heating, cooling equipment in buildings make almost a third or maybe higher percentages of the total energy consumption. Windows are another good point to start from. In the next couple of slides, I would like to show you samples from net zero energy building that are seen around the world. These two are for residential, single family and multi-family house. This is an office building in Lehigh Valley. This is a contemporary home. I put this there to show that not only new constructions, but historic buildings can also be converted to zero energy buildings. This is also an interesting example. Joyce Center in southern Ontario. This is actually an educational building. So you have these great solar panels which account for almost all the energy demand of the building. Okay, so the renewable energy is an important part in defining zero energy buildings. Therefore, we must take into account active systems such as photovoltaic panels, hot water collectors, and also heat pumps. Here, the heat pumps are quite important, and I will come back to that in a little bit more detail, because heat pumps can allow us to convert existing buildings into nearly zero energy buildings. Okay, so that is an important tool that we can use to achieve this transition that we are looking for, decarbonized cities. Member states have, of course, targets primary energy use around 50 kilowatt hours per square meter per year, which is not a very low number, actually, if you want to achieve net zero energy buildings. In Turkey, we have a software already, which I will mention at the end of my presentation, BEPTR. So technological solutions are already available related to thermal insulation, triple glazing windows, energy efficient heating, cooling, lighting, appliances for integrating renewables. So in terms of the technology and the market, we are there. The main problem is they may be a little expensive at the moment, but that expensiveness and being economical is recovering very quickly, especially with the rising energy prices at the moment. Okay, so we start from proper insulation, because to achieve a zero energy building, first you must cut down on its requirements and its usage of the energy. So the best way of doing this is to insulate it. So the smaller the heat losses and gains of the building, the better a chance you have on switching to a zero energy building. So let us talk a little bit about the climate change actions that have been going on. Recently,
we have, Professor, we have 15 minutes.
yes, I will
okay.
speed up. Don't worry.
Okay.
In year 2015, United Nations Climate Change Conference, that was, I take that as a starting point because that is the first COP meeting where the global warming was first made so important. And the emission of carbon dioxide, especially, which is related to energy production, is very important. The latest job 26 was achieved in 2021 last year in Glasgow, and there I wanted to take a minute on that because there were some points made up there, and the way that we are achieving right now, the target is 2.7 degrees. So if we don't do anything, the rise in the temperature will be 2.7. Okay, if we do achieve some of the achievements, this would be 2.5. That is the commitments that the states have been making that they will reach in year 2030. 2.4 is still a high number. And 2.1 if the targets are implemented. And of course, the existing targets therefore remain completely inadequate. That is, the convention there, the conference has pointed out very clearly that the targets at the moment are not inadequate. We must do better than that. Otherwise, we can't achieve the target. Okay. So what should we do in doing that? Well, widespread use of natural solutions. This is one of the remedies, and of course, new energy infrastructures. Okay, so those two issues are very important, and this must be taken care of countries very quickly. Okay, so here again, a summary of what we should be doing. We must achieve climate neutral solutions. We must achieve electrification and decarbonization. These are two major developments, experienced energy systems, and we must use energy efficiently. And hydrogen technologies and sustainable bioenergy technologies are promising candidates to realize the transition. Okay, so these are some scenarios which I will not talk about. They show what we have been talking about. If we don't do well, we will be going up to temperature increases of, in fact, 3 degrees. Okay, so Turkey is a part of the Vienna Convention, and Turkey has been doing fairly well on following the European Union. These are dates that we have been passing recently to follow the protocols that have been signed internationally. Okay, we have, of course, National Climate Change Strategy document and energy efficiency strategy documents that have been already issued. What do they achieve? Well, by 2023, the energy consumed per gross domestic product, which is an indication of the energy intensity, will be cut down by 20%. That means we will be using energy more efficiently. Okay, and Turkey has signed the UN Framework Convention on Climate Change, the Kyoto Protocol, 12 years with a delay, but we have already signed it. Okay, and what else? The Kigali Amendment, this has been signed recently as well, a year ago in March 2021. So we're doing well with the following of regulations. And the F-gas regulation is also issued in 2018, which is also not a bad date. Here is a tendency. The blue one shows if we don't do anything, and the green lines are our predicted or declared predictions. This is what we have promised to do. The Green Deal, of course, Europe has set forward their goals. One of them is the European Green Deal. We are all aware of this, and therefore I can pass this part very quickly. The two documents define the European Union's expectations and give clues to end the COVID-19 era. What are the basic issues? Hydrogen and renewable energy occupy an important place here. And here are three statements that I have summarized from the Green Deal. We must reduce energy demands of buildings. We must use efficient technological solutions for buildings, and we must integrate renewable resources. How do we do that? Well, we must use efficient products, of course, and another very important issue is the cost-benefit approach, because we have been using actually a optimum cost analysis up till now, but this is not enough. So we must also include how the society looks at these measures and the transition, and that gives us the cost-benefit approach in terms of the strategies. And the new energy performance buildings directive has also been looking at these issues. Comfort and health are two new concepts that have been introduced into the directive, and the smart readiness indicator, that is the control electrification part of the directive. What is a cost-benefit analysis? We must also look at the external effects in the evaluation, like the economic dimension and the financial analysis and the social perspective of the society, not just concentrate ourselves on buildings and technologies. And therefore, there has been a proposal in the last month of last year to revise the directive to bring these more into the picture, social action and so on. Okay, I want to just emphasize these last three things. What must we do in this proposal? National building renovation plans should be taken into account, because we must also take care of the existing buildings. So energy performance certificates should be issued, and renovation passports should be. These are new concepts that have been proposed for the directive. And during the modernization, we must use energy efficient systems. There is a very important project that we are, as Aydın University, are taking part of, called CoolUp. This is a project that has been financed by the European funds, and what it does is it concentrates on the sustainable use of cooling in the North Africa and Middle East region. There are 4 partners: Turkey, Lebanon, Egypt, and Jordan in it. And of course, Germany is there. The Guidehouse is the name of the party that is leading this consortium. And this new sustainability project aims to use natural refrigerants in cooling equipment and also increase the energy efficiency. Okay, so I will, to use the time, I'm running, I have 5 more minutes, so I will pass this part. There has been a project by Isoder 5-6 years ago to establish the climate zones of Turkey, which is defined in the national standard at the moment as 4 climate regions, but the cost optimal analysis tells us that these regions must be increased to 6. So that is a comparison of the old and the new climate, proposed climate regions in Turkey. And accordingly, of course, the new values have to be redefined for these regions. Okay, now let us come back to renewable energy and electrification. Renewable energy and electrification is an important part of the transition to decarbonized cities, and it is if we look at the latest records, we see that although the COVID era has had negative aspects on our society, we're doing fairly well on renewable electricity capacity building in this region. And of course, the Russian-Ukraine war has actually simulated these activities, because the countries, especially the European countries, now are trying to reduce their dependence on the Russian supplies. Okay, so I think that is the pre-crisis policies led to a faster growth now. And as I have mentioned, the European Union now does not want to depend on the Russian natural gas anymore. Okay, so I will pass these slides. How is Turkey doing? Well, according to 3 scenarios, if we can achieve the best one, of course, that is by year 2028, we can actually change the picture completely, replace the percentage of the fossil fuels by the percentage of the renewables. Okay, I will come to heat pumps now. I know that I'm running out of time, so I would like to share these last slides with you. Zero energy buildings and heat pumps. Heat pumps are devices that transfer heat from different sources. There are 3 types, actually, as we know. One from the earth, ground source heat pumps, from the water, and also from air. This is important. I wanted to emphasize on this because the renovation of buildings depends on heat pumps, I would say. Otherwise, we cannot achieve the transition. And there was a drawback, actually, related to the use of heat pumps, because the heat pumps were not considered to be renewable, because they used electricity and also fossil fuel reserves for the running of the pumps and the alternators. So, however, I'm coming here. Okay, the renewable energy resources directive has changed this issue, and that they have included the part of the heat pumps energy that comes from the sources like the ground, water, or air, is now counted as renewable energy, and that is a drastic change, I would say, a turning point of being able to achieve the transition. Okay, and in the last 5 minutes, I would like to talk on the smart technologies and digitalization. Okay, the modern economies, of course, cannot do without ICT technologies, information and communication technologies. Internet of Things is an important part of this structure. Of course, that introduces other problems like cybersecurity issues also, but we will be able to overcome these drawbacks. Okay, so digitalization is not used in heating and cooling that much at the moment, but the technologies are enabling the use of these new technologies, digitalization in the products. Okay, so DDC systems and the building information management technologies are important here. They depend on the digitalization and the achievement of the big data that is required for the management of these systems. Here is a sample DDC system that we can use in a residential building. You can use the system to control the lighting, the doors and gates, sprinklers, home entertainment, all sorts of functions of a residential home. How do we do this? Well, we have 4 stages. We have sensors, field elements, operation and management. First, we, of course, measure the quantities using sensors like thermometers, humidity sensors, CO2 sensors, and so on. Then these signals are converted into signals with the logic functions, and then they operate valves and dampers to control the system, and they are integrated through a backnet or LON system and processed by the computer, and then this data is managed to save energy and increase the comfort conditions and the security of the building. So you have these elements of that can communicate among themselves, and this is an example of a electronic control system that uses the basic DDC system. Okay, and I'm about to finish. I want to talk about, I did this last year also, the Y generation, because the Y generation is actually dominating the lives, the technology especially, and therefore their way of looking at things is important to understand what's going on. And the freedom of choice, of course, and to be free is their basic goal. So they want to be mobile. They don't want to work in offices all the time. They don't want to work at home either. They want to be mobile. They want to do everything, but and in that meantime, they would like to also do their professional businesses. Metaverse, for example, is an endpoint to this because I'm sure you are aware of the concept, the metaverse. You do your social life and also your business during your internet games. You can go to give a break in your internet game and then go to a concert with friends. You can send them tickets. You can do your business. So you see, everything is being done in a metaverse world. So that is something we will be talking about very often in the future. Okay, and how do we achieve these technologies? Here I try to summarize that also. Cloud computing, mobile computing, surface computing, and networks. These are the key words for the transition. What is cloud computing? Cloud computing is you don't want to use servers anymore. You have a cloud structure, and you do everything in the cloud. What does this give you? What advantage? Well, it gives you the advantage that you don't have to carry professional software with you. You don't have to carry your very complicated servers. You can just connect to the cloud and everything is there for you. Mobile computing, again, you don't want to sit home. You can do your business while you're traveling. The phones, for example, are good examples of this. If you look at the market, you will see that the sales of PCs, for example, are diminishing. Notebooks are now, iPads are becoming more popular, and now they are diminishing also, and we use our cellular phones. Surface computing is the technology that gives your interaction with the computer. You don't want to use mouses anymore. You don't want to use the computer. And then, of course, to do this, you must have a network of sensors and, of course, a very powerful internet system. And one more minute, and I'm finishing up. The energy performance software that we have developed for Turkey. There are different softwares that are commonly used, like the Hub software, Energy Plus, BEP and ISODER software are two softwares that are used in Turkey a lot. Of course, the BEP software is a software that is not for energy performance calculations of for comparison. It is mainly to be able to issue the building energy certificate that I have mentioned, which is now going into the European Energy Performance Directive. So in that respect, I put this especially there because at this point, we are actually ahead of the European Union. They are considering this now and putting them in the directive. This software is already in the legislature in Turkey. So I just wanted to do that, say this because this is something I'm proud of. We're not doing that bad. We should also mention this here regarding this software. This software is based on, of course, European standards, and these are the summary of the standards that have been used in this software. And this is the schematic view that I took from the DIN standard that is the basis for the BEP-TR software. Thank you very much. I rushed through my slides, but I think I took only an extra 5 minutes. Sorry for that.
That's okay. Okay, thank you very much, Hasan Heperkan hocamız. Thanks a lot. Thanks you.